box with a square base, but this time we are told the area is 1200 square feet, centimeters squared. So the area equals x squared plus 4xh, and this is 1200. This time we are looking at the volume, which is x squared times h, area of the base times the height. And yes, from here, we have to obtain h, which is 1200 minus x squared divided by 4x. You can, and I would have separated it into two fractions. This fraction, which is 300 over x, and this fraction, which is x divided by 4. Only because it's easier to differentiate, but you don't have to do this. Really, it's not really important that much. Okay, so now the volume is indeed, at this point, a function of x. So I have to multiply by x squared. So this is 300x minus x cubed over 4. So far, so good? Then we differentiate. We get 300 minus 3x squared over 4. That's fine. So the least common denominator is 4. So then we can differentiate at this stage. We can set it equal to 0, but I prefer simplifying it before I do anything. So 1200 minus 3x squared. You can factor out the 3. That's even easier. So 400 minus x squared divided by 4. And when we set v prime equal to 0, we get x equals 20 or negative 20 centimeters. But negative 20, we should not even write it because it's not possible. Again, this is not enough. I have to determine x. I have to determine h. So how do I determine h? So h is 300 divided by 20 minus 20 divided by 4. So h is 15 minus 5, which is 10 centimeters. However, I have not shown that 20 centimeters is indeed a maximum. I have no idea. So I have to go back to v prime. I refuse to even discuss this. I'm only replacing in 400 minus x squared. So let's replace 0 in this and give me the sign to the left of 20. Very good. Now let's replace this by 100, which will be 10,000. 400 minus 10,000 is? So this is indeed typical for a max. If I want to find the maximum volume, if they are asking me to find the maximum volume, not a problem. So V will be 20 squared times H, which we determined to be 10. So this is 400 times 10 is 4,000. And this is in cubic centimeters. How did you feel about this problem? Ella, go ahead.
I think it was fairly easy.
Good. Excellent. That's all I wanted to hear. Okay. So let's take a look at another. Okay. 37. A cylindrical can, like a can of soda, without the top, is made to contain V cubic centimeters of liquid. Find the dimensions that will minimize the cost of the metal to make the can. A cylindrical can without the top is made to contain V cubic centimeters of liquid. Find the dimensions that will minimize the cost of the metal to make the can. So let's talk about how we should look at this problem. So here is the can, assuming that it has a base. It's open at the top, but it has a base. So the volume of a cylinder is still area of the base times the height. The same thing with the box. Area of the base times the height. Same thing here, just that the base now is a circle. So pi r squared times h, correct? But now, this is the surface area, including the base, which is pi r squared. So how do I determine this? The surface plus the base. Circumference, width times height, or width times length, if you want, doesn't matter, right? So please remember, when we talk about a cylinder, the outside, not the bases, without the base, the outside area is the circumference, which is 2 pi r times the height. Ready? So this is problem 37, same page. So here is the picture. The volume is V cubic centimeters. They're not giving us any numbers. So the volume is V. This is the radius, and this is the height. Find the dimension that will minimize the cost of the metal to make the can. So the volume is V, and now we want to minimize the surface area. And there is only one base. The top is open. So they want us to minimize the area. I cannot minimize a function if I don't have it. So let's see how we create the area. So can anyone give us the formula for the area? Very good. Area of the base plus the surface, the lateral area. 2 pi r times. Excellent. Also remember, we have to write the volume. The volume is very important because once we get the volume, from there we will pull out something. So, can anyone give us again the volume of a cylinder? Very good. So pi r squared times h. So look at this, it has two variables. I am dreaming of removing that one. What should I do and how do I do it in order to remove that? H is? Okay, let's work on this for 1 minute or 2 minutes. It doesn't matter. It's a constant. You don't even need it. Very good point. We don't even need it. It's a constant. If you encounter anything other than what we covered in WebAssign, please bring those questions on Wednesday. Anything you find. So first we replaced h by v over pi r squared. Agreed? Then I realized that I can simplify a pi with a pi and an r with an r. So then a of r is pi r squared plus 2v over r. Okay, I have a function. It's a function of one variable. V is a constant. Don't even bother with it. Don't even look at it. It's just a number, and we don't even care whether we have it or not. So now we have to determine what? The derivative. Very good. So a prime of r will be 2 pi r minus 2v over. Excellent. So we can factor out a 2, and then we have pi r cubed minus 2v over r squared. Sorry. So I factored out the 2. So pi r minus v. So when I multiply by r squared, I have pi r cubed minus v. Good. Now, after I found the derivative, what next? Yes, critical numbers by setting it equal to 0. So a prime of r is 0 means not this and not this, but this. Pi r cubed minus v equals 0, which means r cubed equals v over pi, which means, very good, the cube root on both sides. So r equals the cube root of v over pi. So the question was asking us to find the dimensions of the can that minimize, right? So find the dimensions that will minimize the cost of the metal to make the can.
Sorry, can you take that off a little bit? Can you take that up a little bit?
If you see something, you may be right and I may be wrong. It's okay. Okay, so we have R. Now I have to determine H. And H is V over pi R squared. Careful. So H equals V over pi R squared. Ugly. Quite ugly. So H equals V over pi, the cube root of V over pi. Ooh. Yes, we can simplify it a little bit. Rationalizing with the cube root of V squared over pi squared. We don't really care. Because I can... Well, actually, they're asking us to simplify it, basically. So let's do that. So V over pi times the cube root of pi over V. I guess it's in the denominator, so I have to flip it. And let's see what else I can do here. I can rewrite it as V over pi, which is the cube root of pi over the cube root of V. And I can rationalize the top and the bottom by the cube root of pi squared and the cube root of pi squared. I should only rationalize the denominator, actually, because that doesn't mean anything. So, okay, never mind. So the cube root of V squared and the cube root of V squared. It's not friendly at all. Okay, so this becomes V, which will go away with this one, because the cube root of V squared times the cube root of V is V, and that simplifies. So then the top has a cube root of V. Now, what happens here? This with this will go away with this. So I didn't accomplish much other than the cube root of v squared over the cube root of pi squared, or the cube root of v squared or v over pi squared. That's as far as I can get it. But the whole thing was, so then r equals the cube root of v over pi. But what we did is fine, but I have to show a prime of r with the cube root of v over pi, that this gives a minimum. I have not shown that. If I don't show this with the sign, I can't guarantee that this gives a maximum or a minimum. So I have to go back to a prime, which is this. Of course, I'm not going to plug in anything in here. Nobody cares about those that are positive. So I'm going to plug in 0. When I plug in 0, what sign do I get on this side? Negative. So now this is the cube root of v. I'm going to plug in v, which is much bigger than the cube root of v divided by the cube root of pi. So when I plug in v here, pi v cubed minus v obviously is going to be what type, what sign? So pi v cubed minus v. That's it. So this is definitely a minimum. What was the difficulty with this problem? Well, the fact that there were no numbers and I had to go around everything and just get letters, and instead of getting some numbers in there. No numbers. V is not given to us. Or it is given. It says, well, it's V. Just give me a formula that works for any V. And that's a formula that works for any V. So now if you say V is 1,000, then I'll tell you R is the 10 over the cube root of V, of pi. If you say V is 1, then I'll say R is the cube root of 1 over pi. If you say V is 10,000, then R is the cube root of 10,000 over pi. So this formula works for any V. Yes? Yes. In some situations, we may find a minimum and a maximum. So let me look at a problem like that. Very good question. Thank you. Dimensions, point closest to the point, find the point is closest. I can't see one, but I will come up with a problem for you like that next time. Let's look at something with the cost. We still have time? Yes, we do. Okay, this just caught my eye. 16. A rectangular storage container with an open top is to have a volume of 10 cubic meters. The length of its base is twice the width. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest such container.
How much more?
Yeah, we'll have to read it again. Okay? A rectangular storage container with an open top is to have a volume of 10 cubic meters. A rectangular, it means that the length and the width are not the same. It's not, the base is not the square. But we are given some information about that. The length of its base is twice the width. So what do I have so far? Let's get the problem started and then we'll go back. So back to page 332. If this is x, this is twice x, and this is the height. So one more time, the volume, 10 cubic meters. Open top, the length of the base is twice the width. So the length of the base is twice the width. Material for the base costs $10 per square meter. So for this, $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest such container. So first we have to find the cost of such container. And then we have to find the length and the width and the height so that the container is the cheapest possible. You want to work on it for a couple of minutes or yes? Okay.
Can you put the problem up there?
Yes, of course. Absolutely. Can we start or we need more time? Say it again?
Can you start now? Because I don't know. Can you start now?
Yes, let's start.
No.
Very good. So, perfect. So, the cost of the material is definitely area times the cost per square meter. So 2x times x is 2x squared and multiplied by 10 plus 4. So two identical sides. So this one is x times h times 6 twice x age times 6 and plus twice 2x times age times 6. So base times height, x times age. There are two identical ones, and the cost per square meter is 6. And then two identical ones this way, 2 times x, 2x times age, which is this. They're 2 times 6. Let's see what we have. So for now I have 20x squared plus 12xh and plus 24xh, or in other words, 20x squared plus 36xh. The only problem is, how do I get rid of this h? But I have no problem getting rid of h because I am given that the volume is 10. So the volume of this a box is the area of the base 2x squared times the height, and this is given to us as being 10. So therefore age will be 10 divided by 2, so this is 5 divided by x squared. And that's really all we need to do, besides differentiating and setting it equal to 0 to find the critical numbers, etc., etc. But once I determine the formula for the cost for the base is 10 per square meters, and the cost for the rest around it, surrounding it, the height or the sides, if you want the lateral area, for that I have the cost per square meter, which is 6. So now once we replace h by this, so the cost becomes a function of x finally. 20x squared plus 36x multiplied by 5 over x squared. Is this clear so far? Yes, we understand the steps? Yes? Okay, so now we simplify a little bit. So then the cost of x is 20x squared plus, I think it's 180 over x. Correct me if I'm wrong, please, anytime. Okay, so finally I have the cost function. What now? Yes, I have to find the derivative because eventually I hope for critical numbers, or max min in other words. So c prime equals 40x but minus 180 over x squared. Is c prime clear? Yes? Okay, so now I have to prepare it for setting it equal to 0. Do not just set it equal to 0. Change it into 40x cubed minus 180 over x squared. And this is what we set equal to 0, and we get 40x cubed minus 180 equals 0. Now let's see what happens when I simplify a little bit. I get that x cubed equals 18 over 4, or 9/2. So then x must be the cube root of 9/2. This may be okay, but it's not enough. So here is the function. Here's c prime. Nothing in here is required. I plug in 0. What is the sign when I plug in 0? Very good. What is the sign when I plug in 10? Well, 10 is much bigger than the cube root of 9 over 2. So when I plug in 10, I get 40,000 minus 180. So this will be definitely positive. So this is for sure the minimum because of the sign of the derivative. No question. If I want to determine this, I will find c of the cube root of 9/2. And I have to go back to c. Here's c. 20, the cube root of 9/2 squared plus 180 over the cube root of 9/2. So as we discussed many times in the past, be careful. Just finding the critical number is not enough. We have to study the sign because that critical number may be turning into a max or a min, but we have to show which one. We have about 5-6 minutes left. So what would you like to do? This is the end of the material for test 3. No more new material. So maybe we should discuss when we want to take this test. We haven't reviewed, so meaning that we have to have one session to review. When would you like to take this test? It doesn't matter to me. It can be Monday next week. It can be Wednesday next week. It's up to you.
Possible.
I'm sorry?
As late as possible for me.
Soon, you said?
Wednesday.
Or late?
As late as possible.
Oh, late. Okay. So what about not this, a week from this Wednesday? Will that work?
Yes.
Is that enough time? So let me